Today, I am going to talk on Apache Beam, and we are going to understand the basic concept and what are the use case, and as Apache Beam, what kind of features they offer, and at the last, I am also trying to give the demo how you can start if you are interested to do the coding part. So at the last, I'm going to demo how you can set up the code base, how you can write the code, how you can run the code, and so that you feel comfortable. Whatever the concepts we discussed theoretically, same you can do from our code perspective as well as. So let's talk Apache Beam. Is the first thing. This is an open source unified programming language, you can say modeling language, that's for both batch or stream data processing pipeline. So if in our applications we are dealing with the batch processing or online streaming, where the you want to do your data processing in parallel way. So in those scenario, Apache Beam help us to build those pipelines. This is the good part. It is the open source and unified model for the defining both kind of data processing, maybe batch processing or streaming processing. In later part, we'll talk what do you mean by batch processing and streaming processing. The objective of the Apache Beam to do the data parallel processing. What do you mean by parallel processing? That means here, whatever the source, whatever the data you are as a stream data comings, Apache Beam provide options. You can process your data with a multiple worker nodes. That means your data are processed by the runtime environment in the multiples worker machine, you can say. Okay, whatever the cloud provider is using, that's help us to launch. So due to the say they are Apache Beam is designed, you can go do the data processing, but your data is very large or real time streaming, then you want your data can be processed parallel. That means that's our processing happen in the multiple worker node at the same time. Okay? And good part is that it's allow we can write our data processing logic once and run it on the multiple execution environment, you can say runner. So here, whenever you think, hey, I have a data processing requirement and I am going to the build my processing pipeline. Okay, and once you process the data pipeline, okay, you build the pipeline, and in the particular programming language you build the data pipelines. Now you want to run. So lots of technology have a inbuilt you can say capability to run the program, but here Apache Beam say don't. You just build your pipeline in couple of language which Apache Beam support, and you can execute, you can run this pipeline on the multiple runtime environment. We'll talk what all are the runtime environments. So here the very decouple between your programming model, which programming language you choose, according to the Apache concept, you can build the pipeline, and this pipeline you can run on your requirement, your budget. Maybe you want to run on the Google Cloud, AWS Cloud, Apache Beam, or some different runner, Google Talks. So Apache Beam is not very tightly bound with a programming model, with a pipeline, and with a runtime environment where this pipeline you are planning to run. Okay, so these are very basics. So high level, the use case of the Apache Beam, that means whenever you want to do data processing. Data processing, that means whenever the particular event, data, logs, message come, you want to perform some set of function. Let's say one function to validate data, another function to maybe uh, uh, transformations or validity checking, conversions, and then finally, after couple of function, finally you want to whatever the final outcome you want to store somewhere. Maybe you pass to the another downstream applications or database or so. So here the concept of your source of data from where data is coming, and here you can build pipeline is just nothing. You can define a set of functions can be executed in a particular array. Function once, let's give validate input. Function two, let's transform a particular a input to the b input. Function three, let's calculate some average calculation, grouping something. Set a function you want to perform on data. So those individual functions can combine as a part of one pipeline. So pipeline need one. First, you need a source from where data come. Data can be batch data or online streaming data. You, according to the Apache Beam guidelines, we build this pipeline, and this pipeline, excuse me, this pipeline, once built, that can be run on the different environment according to your need. And after the running pipeline, whatever the outcome come, you can again push to another sync or database or any cloud, whatever the place you want, you can do. So these are the basic about Apache Beam. So let's talk this whatever we discuss like here Apache Beam. If you go to the official website and you find they claim these are in the you can say unified programming model. Here I am talking about the source and you can say sync. Source can be here maybe source maybe your Kafka, Ebro, Big Data, or any applications they are generating data. Okay, and here the same pipeline, whatever you are building, that work for the both maybe batch processing or you can say maybe your you can say parallel batch and streaming. And the beam models internally defines how you can connect your pipeline can connect to the multiple source or sync via IO connector. These connector already defined by the beam model. And once you want to choose the language, because you want as a software engineering, whenever you're going to write the pipeline, you have to choose the programming language. Which programming language you are going to select? Maybe here support Python language, Go language, maybe Java language, other. So mostly data scientists are using someone Python, the Java community background are using Java language. So this is this is a free event tool. And similarly, the runtime environment where you are going to run your applications, maybe like a Flink runtime environment, Google data flow environment, maybe you can directly run without any on a local machine. You can run using the direct runner. I'll go to show the demo in the direct runner. Okay, and even you can run on the Spark runtime environment. So these are, you can say, a couple of options. We have options about the runtime environment, about the source sensing. So Apache Beam is given very simplified, unified programming model where you build your pipeline. Pipeline can connect to the source, can connect to the sink, and for that they have already built the IO connectors, and you can programming model. Okay, so if talk about the unified model means just write once and run anywhere. That means here you can just write program in one, and if you want to run Google Data Flow, you can run a Google Data Flow environment, or you can run on the Spark environment, you can run another different environment, you can run. So there is a no tight coupling between the runner runtime environment and your code. Here, say both batch plus streaming, whenever you're writing a code, same API as a Beam suppose for the both model. So sometime your data have a fixed data, or this is the 6 month data, 2 month data, I want to batch process. The same API, same pipeline you can run for streaming, same pipeline you can run for the batch. And I mentioned this is the runtime environment runner. Runner is a pluggable. That means the whatever the base engine you want runtime environment, you can choose. Apache Beam is not forced. You can choose only this. Okay. Similarly, main focus on the Apache Beam about the scalability. That means by designs, this Apache Beam for designed for the large scale distributed process. Okay, so whenever you have a your application is a distributed model and you have a large ecosystem where you want to kind of a data processing, so Apache Beam is fit generally in a learning concept where you need to processing lots of data. In those case, you can say Apache Beam fit. And if you talk about the Apache, whenever you want to, let's think, I need Apache Beam, you have to choose the Apache, provide the SDK. Means how, which language. Currently, if you talk about the Apache Beam, so they have a Java SDK, they have a Python SDK, they have a Go SDK, and if you want similarly kind of available Scala interface as well. So mostly if you talk about the data science or machine learning, deep learning, these are the mostly language used is the Python, and nowadays slowly go also going to pick up, but major software we talk mostly software in Java language. So Apache Beam support mostly written programming language Java, mostly data scientist community which are prefer to use the data processing Python. So these are the supported language, and Scala as well as. And if you talk about the once you build the pipeline, specific Java language or Python language or Go language or Scala interface, whatever. Finally, now you are free. You can run. Maybe you written your pipeline using the Java language. Now you are able to run this on the maybe direct run. That means you can run on your local machine, or you can use the Apache Flink or Apache Nemo Runner or Apache Spark, you can say, or even the Google Cloud Data Flow, or lots of runtime environment you have. So you, according to your project configuration, your planning, you can choose any one of the runtime environment where you can run, execute your data pipeline. So these are the basics. Whenever you decided in our applications, we have some batch data. I want to do the data processing. We have a large data set, distributed environment. We have a selected view. So before going to the build pipeline, first we have to understand the basic of beam as a beam model. So these are the some terminology which a specific Apache beam designs, and whenever we as a software engineering going to the build a pipeline, we have to understand this concept like a pipeline, what is a pipeline, and PCollection, PTransform, aggregation, user defined function, runner, windowing system, watermarking, triggering, lots of basic concepts. So we're not going to discuss all these concepts here, but mostly that's required to the right pipeline you must aware. All right. So let's talk about what's first and most basic things in the pipeline. Because pipeline is the main component, or you can say part of the Apache Beam. Finally, if you are going to use the Apache Beam, that means at least you have to build your pipeline. So what is the pipeline? The pipeline just encapsulate your entire data processing task. Finally, why you choose the Apache Beam? I have a data I want to process them. So from starting to end, whatever the data processing, you want to read data, you want to validate data, you want to convert data, you want to transfer, you want to aggregate, you want to save some data, and finally you want to store somewhere, send somewhere. So all from starting point to end to finish, till finish, you have to build your pipeline. For each activity, you are defining some different setup of functions. So these set of function you can say combine in Apache known as a pipeline. So pipeline is a entire data processing tasks. Multiple tasks can just combine them, make from starting to end in a particular sequence order. Okay, so you can say pipeline is also you can consider pipeline is a sequence of steps, because whenever you plan to do data processing as a business requirement, you know the first I am going to this, and this. So whatever the sequence you have according to the business, each business have a different model of data processing. Right. So generally these sequence of steps are you can say sometimes transform. Maybe first thing, whenever you are planning to data processing, where to read the data? First, you have to choose data from different sources. So that is considered as an input source. And again, second, as a business requirement, you have to choose how to process the data. Means what kind of transformations or what number of steps like validation, like transformation from one form to another form, like encapsulation, like enrichment, like lots of things you can do while the data processing, aggregation, summation. So all these come under your transformation part. So main your pipeline as a engineer, our responsibility to learn how the Apache Beam support what kind of transformations you can use to build your pipeline. For each transformation, you have to need source of data, and finally, where to write the result. Once your transformation happen, finally you need the source and sync. So these two steps, each for same for every pipeline. But the only difference is here you have to think according to your business how you are going to transformations. That means data processing means you are doing something. You are going to execute business logic, business functions, business requirement. Those are come as a part of your data transformation. So mostly Apache being focused how you can transform your data. right? So pipeline just this the steps, and generally whenever you are going to use the pipeline, generally say you just write one driver program, or you can say a main program where you have to create at least one pipeline. So good part to creating a pipeline, whatever the terminology, same the models also used by the Apache Beam. The Apache Beam may specify one pipeline, and you can create a pipeline. And once you create the pipeline, now you feel free where you want to run this pipeline, right? Okay. So next, most useful Apache basic model is the P collection. Generally, whenever your application going to read data from the, this is a source, you are going to data read and receive by the P. So once data receive, somehow we are going to collect them. So if you talk about in general language like Java language or any language, they provide the concept of data structures to holding the multiple event or multiple masses. Okay, so if we find a data structure talk about the array or list or collection, so similarly they are using the concept like collection. So but here say P collection. P collections is the immutable distributed multi-element data set. That means they have a multiple element or event considered in the one P collection. Okay, but notice, but this collection or set is designed to work in a parallel across the multiple worker machine. So this collection is not a simple collection. This is designed as such way that this collection can be processed parallelly in the multiple worker. Due to that, say P collection. If someone say get parallel, you can say the P collection is designed in a such a way if the collection have a data or elements, events so many, then our runtime environment automatically uh, scale our worker machines and do processing on the multiple worker side. Due to that, the parallel processing, you can say, distributed processing, you can say. Okay. So whatever the source of data you receive can be either bounded or unbounded. So generally, whenever you talk about data coming to the system, that can be either bounded or unbounded. So what do you mean by bounded and unbounded? Similarly, these P collections also can be bounded P collections or unbounded P collection. So what do you mean by bounded collection? Bounded collections also a data sort, data sets known as a fixed size, or you can say alternatively a data set that is not growing over the time. So that means a bounded collection. Means you know ki this 2 file, yeah 10 file, this is the file, this fixed file come from, they are already stored somewhere in your different application database something, just you want to read them and process them. Okay. Those known as your bounded collections or P collection. Whenever you are going to perform bounded P collection, that is also known as a batch processing. Batch processing means you have to decide first 100 byte data I am going to process. One batch up, another batch, another batch. So generally, instead of we are going to process one event, instead we are going to process the batch of maybe 1,000 event. The 1,000 event come as a one P collection. The P collection can be bounded. Bounded means where we know the fixed size of the collection, right? Unbounded, that means the data set that grow over the time. So whenever we are not sure like sensor data, IoT data, they continuously generating data. So we're not sure they continuous generating data for us. This is known as a streaming pipeline. That means our data is over the time going to generate, and our application going to read, continuous going to reading. Generally, this is the live event happening. Our application continuously reading those data. Those for those kind of P collection known as a unbounded collections. That means data is going continuous basis for us. So, and the elements are processed as they arrive. Whenever one event generated, going to the system process. So this is the continuous processing. This kind of pipeline, you can say, is streaming pipeline. So streaming pipeline, that means unbounded P collection. Batch processing, that is bounded P collection. In a batch processing, we know the size of input elements. In the case of streaming pipeline, the elements are continuously coming to the system and system going to do processing. And whenever we think P collection not just consider is the one element, one events which generated by the particular devices. Whenever they are become a part of P collections internally manage some more attribute associated with this event. Let's see, one events are generated a particular time. So each event in Apache Beam have one timestamps. That means every element in the P collection has a timestamp associated with it. and and whenever your source, this is the source, when they are sending data here, so here also in the case of your continuous data crumbling, you are doing the streaming pipeline. So in those scenario, our system are going to perform some aggregation, maybe some intermediate calculation, some are average of 5 minutes, 10 minutes. So there is concept of windowing. So somehow after whenever 10 element come, after this element, I whatever the element I receive, I want to calculate some and just emit the result, push the result to somewhere, maybe database, some other applications, somewhere. So those scenarios, there is concepts of a watermark. Watermark is just a time estimation time when our processing pipeline assume now we have received the element whatever we are expecting. Let's calculate them and push to the emit data to the further intermediate result storage. Windowed elements. Nowadays, whenever you are any element come in a system, that's is become a part of P collection. So P collection internally logically group the event on the window. So what let's say they create a window of on 5 minutes. So 5 minutes, whatever the data come, that consider under one window one, and after that new window created. So there is concept generally whenever your element come, Apache Beam is consider a concept of window. That means every element in the P collections reside in a window, and no element is reside the multiple window. So let us example ki we created a window of every 1 minute. The 1 minute window, then another 1 minute window, then another 1 minute. Any events generated that some may belong to this window or may belong to this window, may belong to this window, depend upon the timestamp key. So generally, whenever any event generate, timestamp means original when the particular logs are even generated. Okay, that's known as the event timestamp. And once generated those events, they are going to the part of pipeline. And one pipeline going to the do processing, that is known as a processing time. So processing times and event times are the different. Event times, the timestamps are the actual when the events are generated. Processing times, when those events are received by the pipeline and started pipeline processing and finish the processing. That is not a processing time. Okay. And notice these all the windows can be executed in the multiple worker. Maybe one P collection have a lots of data. That data can be executed in the multiple worker node. So those scenario data can be internally transferred from one machine to another machine. So for that, your data must be required some serialization and deserialization. Generally, data transfer in the form of the byte string. So for those scenario, there is a concept. Every P collection has a coder. Here we can specify what the mechanism we are going to use for the encoding and decoding. Whenever data going to transfer from one machine to another machine, in those scenario there must be encoded data with the serialized data. Whenever they are going to process by the machine, at that times they require to deserialize so that the processing can happen. So for those scenario, generally every P collection associated with the coder. And every element in the P collection must be go in the windows. So we have some window strategy. We're going to talk detail ki what is the window strategy, but every P collection has a window strategy, which specify the essential information about the grouping and triggering operation. So window staging say what are the strategy you are going to make a window and the number, and once window created and once window closed, and how you are going to trigger or emit your calculated results, yeah, group value further storage. So that is come under the your windowing strategy. So just high level, you can say in the P collections, we have a following attributes nice, like timestamps, watermark, window elements, coder, and windowing strategy. This helps Apache Beam to do parallel processing. And once we understand P collection, there is one more terminology, P transform. What do you mean by this? P transform represent the data processing operations or the steps, and you can say P transfer provide transfer processing logic in form of function, maybe user defined function, or you can say user code. So here now Apache Beam software engineer responsibility to write some function, means I want according to the my business transformation happen. So here P transformation allow us to write the user code, and user code is applied to each element of the input P collection. So whatever your input come, it's become a part of your P collection, and from the P collection, you are going to perform some user defined function, some transformation, and each and every element. So every P transformation take one or more P collection as an input and perform processing function that you provided on the element that P collection has and produce zero or more output P collection. So that means your your input, you take input from P transformation and do processing and again provide as a P collection output. P collection. So your input is the P collection, output is the P collection. Between that, you can do P transformation. That means your functions, whatever the function you want to perform. So similarly, P transformer can be here source transformer, maybe processing transformations, or you can say conversion operations and output transformations. Generally, we have a three basic pipeline. Source, maybe you are reading or maybe generating data. Okay, source transformation has no connectivity. Just source from where you our pipeline take input. So from this, maybe read or some create data from where our pipeline can take input. So after that, you are going to do processing or conversion for that. So lots of you can say interface exposes by the Apache Beam for the uh, Beam developer. They have a par-do function, group by, co-group by, combine, of flatten, partition, count, lots of conversion operations interface they already exported. Some are already provide the implementation for us. We have to use these functions to write our own transformation. And even you want to some user defined functions, you can your application specific common or composite or combined transformation also you can write. So they have a open lots of interface abstract classes they provided. You can, for example, combine, you want to use the existing Apache Beam combiner, or you want, no, I want to write my own combiner function. You have a abstract interfaces available. You can implement your, you can write your own combiner. Okay, so sometime on average lots of Beam inbuilt API help us, but sometime our custom business logic say no, I want to different transformation, different combiner strategy. So you can customize for in your user defined code as well as. And whenever you talk about the transformation, that means you can perform some kind of aggregation. Aggregation means computing a value from multiple, maybe one or more into elements. So whenever sometime you want to aggregate maybe one, two, three, lots of events coming and you want to aggregate them, you want to perform summation, count, max, mean, average, all these operation you want, where this aggregation function help us. So aggregation is just to group all the event with a common key or a window and combine each group of element using the associative, whatever the associativity and commutative operation you want to perform, plus multiply, division, whatever. And if you talk similarly, a reduce operation, you can say here, your input come multiple input, you are going to reduce them and make some aggregated operation. Sometimes in the map reduce model, whatever the reduce operation, similar like here the aggregation functions we have. The sum aggregation function like you have a count function, sum function, max, min, group by, combine function, combine per key. These are the aggregation functions Apache B model support, and we have to use as per our business need. And mostly, whenever we, as per our custom business requirement, we have an option user defined functions. So to write your own custom logic, you have to run your user defined code. So the way you can write lots of interface already, yeah, abstract classes provided by the Apache B model, we can just maybe we are going to right, the in the demo you can see how we can use the par-do function. User defined code specify what operation you want to apply in every element, whatever the element you want to do some specific things, you can use the par-do function. Or combine, how you can how specify the value to be combined, maybe some. Or similarly DoFn function, per element processing function. Whenever you want to every each element specific function you want to perform, then you can implement your DoFn interface. And similarly window fns, like windowing strategy like group by, combined by, or you can say combined by. So whenever you want to some associativity, commutative aggregation like a plus and other state you want to perform, so these are the models already available in Apache Beam. Uh, Apache engineer must using the do function, do weapon, combine, and combine FN. These are the things we use. Okay, so the core of the streaming pipeline about the windowing, because the your data is continuously coming in the system and now you are going to do processing. The surely after processing you want somewhere your data should be emitted. So on which times, what the strategy for windowing Apache B model has, so you can say couple of. So here windowing is subdivision of P collection into the windows according to the timestamps of its individual elements. So every elements have a timestamps, and according to the timestamps you can create the windows for different strategy. Okay, so windows enable grouping operation over the unbounded collection and divided collection into the window for the finite collection. So here let's see, continuous elements are generated by the my application. Okay, so somehow we are going to group logically first 10 element and then next 10 element and do some calculation, average, count, sum, max, mean, some graph. So those scenario window help us. So each element in the P collection Q must be in one window. So whenever you are going to selecting windowing strategy, you have to ensure that your elements must belong to the only one window, not belong to the multiple. So a calculation can be wrong. So due to that, Apache Beam model provides the different kind of windowing strategy. Maybe fixed timing window, sliding time window, per session, or you can say session or the global window. So these are the fixed, sliding, session, and global window. These are the couple of strategy as per our application need we are going to choose. So let's talk a little bit about the fix, because these are the very key concept in the terms of your Apache Beam model to understand how windowing strategy work. These four strategy according to your business use case you have to select, maybe fix or maybe sliding or session or global. So let's talk one by one. So here, very simple and easy to understand fixed time window. Sometime maybe talk about the Spark, they are talking about the tumbling window. But this represents a consistent duration and non-overlapping time interval. So, for example, like 30-minute duration. So we say, hey, whatever the continuous elements are generated by my application, continuous elements are coming in my system. But I want to do processing every 30 seconds. So whatever in 30 seconds, what the number of element come, I want to do processing every 30 seconds, every 30 seconds, every 30 seconds. This is the fixed window. So all the elements come under these 30 seconds are we are going to group them, sum them, aggregate them, whatever function you want to do perform. So this is fixed window, and in this case no over. So once one window is started, after 30 seconds whatever the element come, close them, and then new window again is started. Then once closed, then new window is started. So see there is no overlapping. So first window 0 started from 30 second. Once 30 second window closed, new window 1 is started. Window 1 30 second closed, window 2 started. 30 second after window 2 closed, window 3 started. So this is a fixed site. There is no overlapping between the windows. So this is known as a fixed time window stretch. One is the sliding window. That means you say, ki, let's this is the data coming in my system, continuous coming in the system. Okay, continuous. So here say I have a window of 30 at 60 second or 30 second. Let's say you have a window of 30 second or 60 second. So this is the window of your 30 second. Okay, 30 second. Now in the fixed window, once this window closed, then the new window started. But here say in sliding window, sometime also the hopping windows. So here represent the time interval and the data streaming sliding window can overlap. That means ki window one started from here. Let's key this is the and after 30 seconds, let's key this is 60-second window, and after 30 seconds again I start another window for the 60 second. Again after 30 seconds I can start another window. So here your window size is fixed like a 60-minute window, but the one window is started from the every 30 seconds. So for example here your window 0 started at this point. So here window 1 is your window 1 right now. This is your window 1 window. This is the window 1, but window 2 started after the your 30 seconds. So new window again started from here. Window 1 started. This is window 1 started. So notice the one window 0 is still going on, but after 30 seconds, I again started new window. Again maybe after that again window 1 started, then window 2 started. So each window have a size of 60 seconds, but the new window is not started after 60 seconds. They can start it after 30 seconds. So after here say 30 second known as a window period. So if each 30-second new window going to start it. Each window size is the 60 second due to the known as a sliding window. One the notice here window 0 is still going on, but window 1 also started. Window 1 is still going on, window 2 started. Window 2 is still going on, window 3 started. Each window is going to close after the fixed size. The here window size is a fixed, but new window is started after fixed duration each 30 seconds. So here one window is still running, another window started because our window starting time is the 30 seconds. So this is known as a sliding window. Okay, so each window strategy we have to study it. If you want a deep study, you can just visit the official documentation of Apache. Visit Apache website and what are the use case where what the scenario you can use the fixed window size, what the scenario you can going to use the sliding window size. But Apache Beam model support these kind of window strategies. So one of the most commonly used in the machine learning is the session based windows. So here like in a fixed or sliding fixed window, we have a in the case of fixed window we have a fixed timing, and once window closed another window is started, once window closed another window is started. But in the case of sliding, hey, window size is fixed but new window is started before closing another one, before closing another window is started, right? So sliding window. But here session, this is the window size is not fixed. In the both case, fixed window or sliding window, your session timing is fixed. Only the problem, only the strategy was when new window started. In the fixed, once window closed, then new started. Once closed, then new started. But sliding, no. Once window running on, new window can start it. Once running on, new window can start it. Right? In the case of session, this is the dynamic nature. So this is known as a, also considered as a determine the gap of inactivity events. So for example, here, so let us one session started. Okay, any element come within this time, okay, new session. When new session start, question that when session going to the close. So this is known as a gap duration. Let's we decide our gap duration in maybe, for example, here we have a let us we have a events come on the one event come at the 10 second, 12 second, 14 second, 30 second, 32, 30. So let's these are the events are in this particular time sum generated. So here let's whenever any element come in the system, one session window is started. Okay, so let's keep 10 second, one session window one is started. Session one is started, 10, 10 come here, 12, 12 come here, 14, 14 come here. So all come under the within the 10 second. So here our gap duration we consider as a 10 second. So you notice 10 here 10 again next come after 2 minutes, after 2 seconds, sorry. So 12 also come under the same window. After 4 seconds again come 14. So this notice next come after 16 seconds. So here gap is the 10 second. That means now the current session which are running are going to the close because the next elements are not come under the 10-second gap. Next window come after the 16 second. So our gap duration is 10. So our current session is going to the close. Once new element 16 come, new window is going to session 2 are going to start it and put in the 16. Next element come 32 after 2 seconds. Gap duration is 10. Still they are considered in the same window. They are going to again 30. 32, right? So here notice 30 and 32 both data come under the 10 second. That means this is the second window. Notice next element 90 come again after 58 second. This is the more. So after 10 second. So notice whenever data come and after 10 second no data coming, that this session is going to the closed. So gap duration say, hey, gap duration of 10 seconds. If any element come element note, come element note, come element go in the same session, and no element coming and duration going to the gap duration 10 seconds. After 10 seconds, no element received. That means current session window going to the close. So this is known as a session windowing strategy. So here the steps like whenever any elements come, the new session is started. So let's say element 1 come, new session is started. New session started, element is stored in this. Another event arrive within the gap duration. Let's we decided a 10 second of gap duration. So next elements come within the 10 second, that go the same window. Again next element come within the 10 second, go to the same window. So this session window can be expanded if the element coming within the 10 seconds. So let's key here after 30 seconds, you notice no more data coming next 10 seconds. So this session going to close. So if no events arrive within the gap, session is closed. So our beam model say we have gap duration 10, no elements come within the 10 second. That means I am going to close the current session. So and now any element come after this 10 second, again you can say new session will be started. So this is concept of your session window. So this is the very good example here I explained so that you can easily understand. For example, here all the events like a 10 second, first element at the 10 second and 12 second and 14 second and 30 second, then 34, then 60. So let's here gap duration of 10 second. So surely 10 second, first element 10 come, go to the session 1, session 1, 12 after 2 second, within the gap, go to the same session, 14 after again 2 second, go to the same window. And now after 14, notice 30 near about the more than gap. Gap is the 10 second. After 10 second, this session going to the close. The session 1 going to the close. New element come after 60 second. So again new session going to started. Session 2 started. 30 stored in the second session. Next element come after 2 seconds. Gap of 10, it's okay. Going to the same window. And after that, no element coming. After 10 seconds, session 2 also closed. And they notice after again 58 seconds later, one new element come 90. So new session is started. So here session 1, session 2, session 3. The different depend upon the when event come, the new session can be started. If any element come within the session, they are going to expand it, the session. So this is the very basics about the session window. Okay, and if you look back here example, session window, just like a function that contain the gap duration of another element. Like here, one window is started here, one window is started here, all the element coming, okay, going to this window, but our gap duration, no window come, no element come, this is a close. Again new element come after gap, again new window is started. All the element coming within the gap, they are going to store, and after stop, and after the gap duration no element come, this going to the close. Maybe after that, after gap, again new element come, new window started, and after that no element is coming, then again this window going to close, and just waiting. Once new element come, again new window started. So new window is started when any element come, but any element window going to close if they not found any data the gap duration which you specify. So they have a very dynamic, here window size is very dynamic, depend upon the event arrival. If the gap would decide it, let's we decide a 1 month gap. So within a 1 month, if any data come, we are stored in the same session. Okay, so let's say in after 1 month, no one, let us example the particular server, if user login today, login tomorrow, login 1 week, login, that means continuously login within a month. That means the particular session going on. But let's today log in, and after 2 months, again someone going to the login. That means a gap duration of 30 months. No particular user will log in the system. That means we can take some decision. The weird scenario, we have to track the particular event. The session window help us. Lots of use case we're not going to talk, but yes, each strategy have a different use case where you can use this windowing strategy. And finally, one of the for the generally batch processing, there is only one global window concept. The by default, all the data in PCollection is assigned to the single global window, and the late data is discarded. If the data set is a fixed size, you can consider global window by default for your PCollection. Okay. So these are the some very four, you can say, commonly used window strategy in Apache Beam model. Fixed time window, also known as a tumbling window, sliding window, also known as a hopping window, and per session, also known as a session window, and single global window, also known as a global window strategy. Okay, so these are the some windowing strategy that Apache Beam model support. We should aware. And I talk about the PCollection is a watermark. Watermark, just like let's we have decided this is my window, and all the elements come. So here our Apache Beam model say, hey, now I am going to close my window because they have some guess. So let us, for example, we have organized some party. So we some guests are coming, but after some time, let's say decided at 2 o'clock, I am assuming all my guests will arrive, and I am going to start my party. So here, guess, maybe we have given period, but so we assuming this is the maximum time at which we can go start the party. Similarly here, whenever our Apache Beam model going to close the any window session, they are assuming at this particular moment for this window, whatever the elements should arrive, that should arrive. So I'm going to close. That's guess is the known as a your watermark. Okay, this watermark also in the case of in the real-time data processing, your data, your events, whatever event generated, that can be come in any order, maybe late. So here you can say watermark just is a best guess to know when all the data in a certain window is expected to have arrived in the pipeline, so that the beam model can be able to close the window and emit the data. So generally, Apache Beam use this watermark concept for when they want to closing window. So before closing window, they have checked what is my watermark. Generally, from the source where data is generated, they have associated some watermark, maybe 1 second, 2 second, and this is also help us watermark help us if you want to emit the result or also incoming data. Maybe if you want to handle on time data or late data, how will decide if any data come within a watermark, consider is a part of window. If any data go outside of watermark, that consider a late data. So what the late data, what the strategy you are going to drop or handle late data, also watermark help us to, hey, what will happen about the late data. So these are the watermark help us to perform windowing functions. Okay, and once your beam model decided now I am going to closing my window, at that times there is a concept of trigger. So when we're collecting and grouping data into the windows, Beam use triggers to determine when emit the aggregated result of each window. So now this window, and now as per watermark we decided we are going to close this window, and whatever the aggregation function we perform on these elements are also going to maybe store data where or downstream application or whatever the place you want to store that's it. By default, if you talk, the beam emit results once per window. When the watermark pass the end of window, both triggers. But now trigger also gives some more use scenario where you can customize this behavior. By default, at the end of watermark, beam models trigger, emit the data, emit the aggregated result. Some scenario where the trigger help us to emit early result before window close. Even you want trigger help us say no, maybe our windows is going too long between the windows. I am going to emit the result within the window. So trigger help us. Even trigger help us how to handle the late data. Some data is not come within a watermark, then how to handle. Sometimes you want to emit the multiple times or more data. Instead of not one emit, you want to multiple emit within a window. So this trigger help us. The trigger help us for the Apache Beam model when calculated window data are going to emit. Okay, so these are the some basics, and if you took about the high level, the pipelines, the flow, how we can do. So talk like here, simple, whatever the source of your source of data, you read data, and your P collection happen here, your P collection, then P transformation happen, again P collection, and you write data, some file system, data where cloud, anywhere you want to send. So this is a very basic pipeline. You can say whatever the data source we have, you have a read data from a IO connector and collect data as a input P collection, do transformation is a P transformation, again receive data is a form of P collections, and again data write to the source, whatever the sync from source to sync you can do. So this is a very basic pipeline you can build. Like you can say this is the linear simple representation of your Apache Beam basic pipeline. Sometimes you have a multiple transformation process on the same P collection. Sometimes let you read, we have a source, from source you read data, make a P collection, and in this P collection, you have a one transformation, we have another transformation, you have another transformation. So multiple transformation you can generate from the one P collection. Okay. And similarly, sometime we have a single transformation and produce multiple output. So here we have a source, you read data, you receive data in the P collection, and from P collection, you define your own multiple function and do different transformation and send the output. Maybe like a part two function, like a function, B function, same input, multiple function, you can also perform. Sometimes you have an option, you can merge the P collection. Maybe you have from the source, you are reading data, your P collection. From P collection, you have a extract some portion, you have a do transfer another portion, and both result P collection can again flatten and merge and make another P collection. So here you can do the merging of P collection and make another P collection as well as. So different use case, different nature, a pipeline you can build. And even sometime our business is say multiple sources. Maybe sometime you are getting one database, some from Kafka, some from PubSub, and for different read, you can create the multiple P collection and make join them and make another P collection, and after that too you can perform whatever the operations on the you want to perform. So you can say different flavor of the P collection or P transformations, or you can flow of pipeline you can build, maybe joining, maybe merging, and other parts. Okay. So whatever the we discussed, these are the very basics about the Apache Beam. So let's talk how you can uh, write the code, write the pipeline, how to run, what are the best, simplest way. So here I am going to just demonstrate. So I'm going to do it from the scratch. So let us I you can just create any or Java project, whatever the using the Maven, because I am using the Java, or you want to Python or any whatever the language you have, but just I am going to show you in the as a Java language. Okay, so if you the Java developer, you know we can create the any Java project using the Maven command. So let's I copy and just create. I am going to create from scratch, so you are aware how to start to writing the code in Apache. So let us just I open any terminal, and here I just paste and run. So they just create one notice. This is the one demo they created, the one above PC Beam. This is the Java, and you can open whatever the editor you use. So let us. I am going to use this project in IntelliJ. So these are the our project. Let's trust this project and open it. Okay. Okay, so this is the application I created, and this is the bug. So first we have to add the dependency of the if you go by default, the Maven created one blank project, and if you run it, it will simply say hello what's okay. So it's good. So now let's first we are going to add the dependency. So whatever the Java version on your machines, you can just use them. So here, this is my project, and I'm in the my machines. We have a like a Java 70. So I set the property. If you notice in my system, Java hyphen version. Remember? Sorry. In my system, I have a Java 17. So I just set the our Maven property. I am going to use the Java 17 on in your machine, whatever the Java version you just set here. And after that, we have to mention our application property file, and we have to add this Apache have a two dependency required. One your Apache core library, and one your runner where you are going to run. Okay, so let us I have just add simple these two dependencies. One, I am Apache core library, and you can just search what is the latest version whenever you are watching this, and just go and select the latest Google. Just say MBN. What are the latest version as of now? So if you notice, the latest version is the 265. So whatever the latest version, whenever you are running, you can use. I'm using the same, right? And similarly, this is the code library, Apache being code library, and one is the direct runner. I'm not going to run this application on the Google Dataflow or Apache Sing. I'm going to run just this program on my local machine. So we have a direct runner. Just as a Java main application, you can run on your local machine. So this is the two dependencies. Now, once dependency done, this is here the code. Here we can write the simple pipeline code. So for simplicity person, I just written simple code. This is very simple way to, I'm going to explain this code. So this is a very simple code we written. Just update your, and here you can just import your Apache S library. So here Apache being library, just create something. Okay. So this is the simple pipeline. Here notice, here we have a just one pipeline already provided by the Apache SDK. If you notice, this is the pipeline class provided by the your Apache library itself. So we have just one create a pipeline object, and after that pipeline, we have a just we have to the function apply function, means what the functions you are going to do for the input, for the transformation, for the output. So here let's key input. I am just a couple of words we have, a couple of words. So here we are create. This is I'm going to use the function create, means key source of data. Here just my same set of words I have. Set of words I have. Okay, and after that I want to transformation. So what the transformation I'm do, whatever the words we receive, we are just going to convert to uppercase, for example. The here transformation logic, whatever you want, you can perform right now. And after that the output. So output, maybe you want to screen, or you want to maybe some output in a file, or somewhere some cloud, some data source, whatever the place, you just write those writer, maybe Google GCP bucket. You just mention the bucket name here. The data going to write that place. Okay, this is simple. Nothing else. Just create the pipeline option, apply function. Here the as per your convenient, you can give the any name. This is just message. If you want to ignore, you can ignore them directly. These here you can source of data, transformation, whatever transformation. I just say whatever the input we receive from here, just to convert uppercase, and after that just write the output data in the particular file. So whenever you run this code, this is the no here by default output folders this program created here, and you can run. So the if you are using editor, it's okay. Using notepad you are to compile, so you can how to run the code. Editor simply run the code, or someone want to come run code from the command line. So this is the command line class. Just go and run from command line here. This is a terminal. Okay, this is the your folder created free, and here, and here just run this command, and they will just go to run this code. Just compile and Java C run your main application name, by default they run. And notice here, once you run the program, the output folder is generated, and notice here the result. Whatever the input I have given, they are created the output form. So even you run from here, or if you are using the editor, you can directly run from your, just delete them and directly run it from here as a main application. Okay, this is the main, just run it. I will just generated them and the output generated. Here you can check your output. Okay, so let's so here the very writing pipeline beam is very simple. Just create one pipeline, and here you can this is the create function that's provided by SDK if you want to create the, because input is the PCollection, so here the collection of data. So this input returns your PCollection. So just either create function, factory function provided by the library itself, and we can use and pass whatever the data. Okay, and here if you notice here we are using the lambda function, like lambda function. If whenever you use the lambda function, you have option, you can use the, maybe you can write the concrete class or you can lambda function. So here lambda function say whatever the input I am receiving here, I am converting and again returning the output. So here this is the map element with every element. This say you have to two string, that means this lambda function return output as a string. If you want to return not a string, I want to integer the count. So here say I want to return like integer. Okay, so integer. So here you can say no, I want to just return the length. So I shall say length. So whatever the length function, so now your function return the length. Okay, so in this way you can do conversion whatever you want to perform right now. Again you want to convert to string, again to the convert. So here these are the operations you can perform right now. So sometimes it's very simple, you can say the pipeline here transformation logic whatever you want you can write. So there are two way to write the transformation logic. One using this map element into whatever the output and via your lambda function. Sometimes person are not more familiar with the lambda function, that times they are writing our own function. So instead of lambda, I can write my own function. Okay, so how to do? So for that, let us I already written on simple same code you can write it in the do function. Okay, so I just written a simple one function. Okay, so just this is the one I written one my same code import. So same code, whatever to uppercase here, I am saying no, I am not going to using the lambda function. I am going to use my apply. Here I can say no. Here just remove this. I can say var to of new and my class. So whatever the class here, you can create one class function, extend DoFn for every element you want to do something. And here your input is your string, your input, your output is a string, your output. Here say process element method you have to override from this. This is the class you have to override the process element, and each element, whatever element you have, just to convert and output out into the output writer. So once you write put, automatically go here, and even you can test from here as well. Remove this, and if you run this code, and they generate the same code. What is output? They are generated the output. Right? So you have a two options. Generally, whenever you are doing some small code, POC kind of code, at that time you can surely use this lambda function because your code is very small. Just use the map into whatever the and the via lambda function. Here you can pass your lambda function, take the input from here and do whatever code. So generally small code, simple code, surely we can use this map element, yeah, flat map element concept right now. But whenever you are writing the custom logics, complex logic, preferable way you can write your DoFn function. You can just write your class and extend and override here multi-line business logic code you can write here. So preferable way in the real business scenario, we also in our application using this class, and we can just write our DoFn function and write our process element, and each element what you want multi-line code business logic you can write here. Okay, so but Apache support both Lambda with the Lambda function you can use to write a business logic transformation, or you can use a simple your DoFn function to write your code. Okay, and one more you can say, hey, instead of reading source data from this hard coded value, maybe I want to read from some input file. So similarly, like they have a IO connector, you can just mention, hey, I want to read data from Google Cloud, some bucket is specified here, just you mention the path of those bucket, and our application can read data from the specific cloud or a specific portion. So let us for example, instead of writing those, so I can say you can simply say, hey, I want to take input from this file. Okay, so let's see. Control. Okay, so instead of writing this, I can say no, I have to take input from this some file, whatever the file name you can mention here, right? So here say dot apply input. Here I can say some file, and here you can create any input text file, input text file create, and put some, maybe here my project I create any input file, new simple file. Okay, input file, and I put any data. Okay, whatever the data we have, that's Apache B. Okay, so that is whatever the data you have, any data you can just, okay, so you can write this whatever the data you have. Okay, so this is the data, your input file has some data, whatever the data, and now in your code base you can say, hey, read data from this input file I mentioned here. You can put any specific path, they read data and apply the transformation, your conversion logic here, whatever the mention, just to uppercase here, or you want to give any message, whatever the transformation you can say. And if you just run this code, and they generated the output. So notice all these lines are converted to the uppercase. Okay. So this is the way you can also read data from your IO connector. This is the IO connector. They are reading data from your file system, writing data to the file system. Here you can give the your maybe Google Cloud some bucket path. Here also give this Google Cloud some bucket path, means ki your application read data from the GCS bucket and do some processing, whatever the processing you want. Generally, par do function and specify your DoFn function. For each and every element, you want to perform operations, and after that, if you want to some group by aggregation function, so lots of group by aggregation function you can do. And I'm not going to talk more, but yes, group by, combine by function you can use, and aggregate data, word count, lots of example we can do. But yes, here my intention, you should just familiar how we can set up Apache Beam library and how we can write our function, what are the different approach, what are the source connector, what are the destination connector. These are the connectors where you can read data, write data. For the doing processing, we have two approaches, two to transformation. One is the lambda function via the map element, flat map elements, and you can perform here your output types, maybe different input, string, integer, key value, anything you can do perform operations. And after that you can do any kind of other uh, operation like your own do function. And after that you can perform some aggregation like count, sum, average, maybe group by function, or you can apply the combiner functions to combine the results. So all these operations you can easily explore and do. Uh, Apache Beam support all these operations. Okay, and if you want to read more details about Apache, just go the Apache maybe overview documentation, detailed documentation. If you want to learn more programming guides, code, example, snippet, everything you can find here. They have all the concept we discuss about how to create a pipelines. They have direct pipelines. What are the P collections? How to create P collection? Even the here sample source code you can find here. You can do create how to reading the external means here how to read data from the cloud somewhere. Just same IO connector square, and you can say hey Google data store. This is our bucket name. You can specify even how to in memory processing you want to do, you can do here. You can specify the coder part, encoder decoder whatever you want. So all the things here, what the transformation you can do here, create mean transformation, what is the side input side output, what is the composite transformation, how to build pipeline. So all the windowing strategy you discuss here, you can follow all the windowing basic types of windowing, P collection, whatever discuss here you can find. Code example you can find triggers if you want to how to trigger emit the real everything is the code snippet example here. You can just find the code and test it. So lots of detailed documentation guidelines available here. If you really want to know more detail about programming guidelines, so you have to check out this official documentation. Here everything's available, your programming guidelines, development life cycle, basic concept, whatever we discuss about the basic concept, each and every concept here, like a pipeline, P-collection, SDK, lots of things mentioned here. For deep and detailed learnings, if you are really going to use in your application, you must have to at least understand the basics and all the programming steps which are given here, how to write your own program. So these are the basics about our you can say Apache Beam, and that is overall you can say I have a points which I want to convey, and Apache Beam. Just refer the documentation. This is the very easy to learn, very you can say powerful tool in the distributed environment. If you want to do parallel processing, I know I have a large data set, online data, streaming data, batch processing, and you have lots of complex business logic. You want to do machine learning processing, some featureization, some kind of concept. You have a learning models. All those scenario, this Apache SDK library help us to write the code. So my uh, humble suggestions, if you are really looking for your business distributed large data processing for the batch and streaming both scenario, Apache SDK is the very suit fit for your requirement, and they have a very flexible programming model, different programming model, Java, Go, Pythons, and different kind of runner you can run on the AWS, you can run on the Google Cloud, you can run on your local machine. So lots of pluggable feature for input, for a runner, for output, and all are the complex business logics. Lots of inbuilt functions available for aggregation, for transformation, for connector, sync connector, IO connector, source connector, every connector available. Just check out the official Apache Beam documentation. That about it. Thank you.